there is a way mathematically to determine whether two elements are going to be bonded ionically, polar covalently, or non-polar covalently. And we do that through electronegativity difference. Remember from the last chapter, electronegativity is the attraction for electrons. And so what we're looking at here is the difference between the attraction for electrons. So, electronegativity, attraction for electrons, can help determine which bonding two elements will undergo. So, I have a little table here that's going to tell us kind of our thresholds, our ranges in which the electronegativity difference falls, the percent ionic character, and the bond type. You're going to be using the electronegativity values that I gave you in class. I believe there's also a copy on my website under Resources and Bonding. That would be a reference tool. Again, not something to memorize, but you do have to know these ranges here. So using those values for electronegativity, if we find the difference, so we're talking about subtraction here, and subtract the two values and find a difference between 1.7 and 3.3. So we have a pretty big difference. One atom is very much more electronegative than the other element. So the difference would be between 1.7 and 3.3. Then we have an ionic bond. Now the percent ionic character is the extent to which it behaves like an ion. Well, in our example with Na and Cl, we have a lot of ionic character here, so you'd expect this number to be pretty high. If you subtract the electronegativity values of two elements, and the difference between them is between 0.3 and 1.7, then it's going to be polar covalent. That means one has more attraction than the other, but it's not enough of an attraction to pull the electron off like in ionic. So these are the things with those partial charges, where the electron is going to be shared unequally between the atoms. And so because you have these partial charges, it acts a little like an ion. It doesn't have the full charges, it just has smaller ones, those slight positives and slight negatives of, like, say, water. If the two atoms are very similar in electronegativity, and so they have about the same attraction for each other, so there's very little difference between 0 and 0.3, then we have a nonpolar covalent. They have the same attraction for the electrons, so they end up sharing equally. These do not have charges, they do not have partial charges, so it doesn't act like an ion at all, so very little percent ionic character. Now, an example of the type of problem that you're going to have on the homework and have to answer and how to use this. It is going to be a difference. So we're talking subtraction, and they're all positive numbers. So it's always big one minus small one. So if I look up Na on my reference page, that's where I'm getting these numbers, sodium is 0.9. Chlorine, on the other hand, is much more electronegative with a value of 3. So if I take big number minus small number, 3 minus 0.9, I get 2.1. That is my difference in electronegativity. And then I look over here, and it falls here within this range. It's between 1.7 and 3.3, so I know this is an ionic bond, and I can prove that mathematically. So this is the last question on your homework. You're going to look at the electronegativity values on your reference page for each of those elements, and just subtract the big one minus the small one, and then figure out which range it falls in to determine the type of bond.